Draw the geometrical isomers of Cr NH3 4 times Cl2 plus. Again, here also we can see that it is an octahedral complex. But the problem here is we have 4 ligands of one type. That is, there are 4 ammonia molecules, ammonia ligands, and 2 chloride ligands. So here we can see that however we try, these ammonia ligands are going to be placed in trans position and as well as cis position. So the decisive factor or the decisive ligand here are the chloride ions or the chloride ligands. So if we are placing the chloride ligands at trans position to each other, then that is, this is across each other. So we can call this the trans isomer, and we can place the ammonia molecules wherever we want in the remaining positions, that is NH3, NH3, NH3. But here the chloride ligands are in trans positions. So this is the trans isomer. Now if we are placing the chloride ligands adjacent to each other, they can be here and here or here and here, wherever they are. If they are kept adjacent to each other, then we can call them the cis isomer, and the NH3 can be placed here in the remaining positions. So here we can see that the ammonia ligands are adjacent to each other. They are cis. Here also cis. Here also cis. But here the decisive factor, the decisive ligand are the chloride ligands. The isomer, whichever isomer it will depend on the position of the chloride ligands. So this will be the cis isomer. So remember, in a compound like this, where it is an octahedral complex having 6 ligands, 4 of one kind and 2 of another, then the 2 or the lesser one will decide, their position will decide whether it is a cis isomer or a trans isomer. The 2 chloride ligands, if they are placed at cis positions, that is adjacent to each other, then it will be a cis isomer. If they are placed in trans positions, that is across each other, opposite, then that can be called the trans isomer.